Integral exponent. An expression has an integral exponent if the exponent is either positive or negative integers. The expressions like 3x, 5x raised to negative 2 plus 2, m raised to negative 8 are examples or expressions with integral exponents. The negative sign in the exponent means the reciprocal. Thus, a raised to negative n is equal to 1 over a raised to n. Similarly, if the expression with negative exponent is in the denominator, get its reciprocal to express the exponent as positive. Therefore, 1 over a raised to negative n is equal to a raised to n. Remember, again, the reciprocal when it comes to negative exponent. Let's simplify the following. Number 1, we have here y raised to negative 1. So in this case, just think for the reciprocal of this one. Of course, this is, if you're going to think about this, you can transform this to fraction form, which is y raised to negative 1 over 1, since all whole number has a denominator 1. And then, in getting the reciprocal, so we can remove this negative sign, this will give us 1 over y. As you can see, this base, which has a negative exponent, has been put in the denominator. So that will be your idea or your hint in solving negative exponent. If you have a negative exponent here in the numerator, you just put it in the denominator to make it a positive exponent, and vice versa. Look at example number 2. 2 over x raised to negative 3 is equal to, as you can see, the negative exponent is in the denominator. So it means you must put this whole expression in the numerator to make the exponent positive, like 2 times x cubed. X raised to negative 3 is now in the numerator, but the exponent becomes positive. Number 3. So in this case, let us solve. So if you can recall the laws of exponent, if you have the same base, or if you're getting the quotient of a variable with same base, you just subtract its exponent. So copy the common base and then subtract 6. Copy first the exponent in the numerator minus, and then the exponent in the denominator. This will give you b, and then 6 minus 8 is negative 2. But to make our exponent positive, you must get the exponent or the reciprocal of this b raised to negative 2. That will be 1 over b squared. Next, number 4. We have here 28a raised to 5, b raised to 6 times c all over 7, a raised to 5, b times b raised to 4, c cubed equals. So let us simplify this first. 28 divided by 7 will give us 4. Let's put 4 here. And then we have here a raised to 5. Since we have the same base in the denominator, we can write it as 1. So 5 minus 5. Then we have here b raised to 6 minus 4. I'll remove this fraction bar here. And then c, which is an exponent of 1, minus 3, which is the same as, which has the same base as c. And then let's simplify this one. 4. Then a, 5 minus 5 will give you 0. Then this b, 6 minus 4 will give you 2. Then for c, 1 minus 3 will give you negative 2. And as you can see, we can still simplify this one. 4, and then a raised to 0 is equal to 1. So I can just remove this one. So times 1. And then I will have your b squared followed by c raised to negative 2. So I need to put this in the denominator. So I need to put a fraction bar. Then put this in the denominator and then change the sign to positive c squared. Then for the final answer, we're going to have here equals 4b squared all over c squared. So this is your answer for number 4. Last, number 5. Just use PEMDAS in this condition. So solve first for the inside of the parentheses. So this 5 minus 2 will give you 3 raised to 5 times, we have here the exponent. Of course, this is a negative exponent, so I can write this into 1 over 3 cubed plus 5 plus 7. Of course, I saw here a 0. So it means this whole expression is equal to 1. So plus 1. Then let's simplify equals. As you can see, we have here, we can multiply this fraction with this 3 raised to 5. So I can write that 1 to 3 raised to 5 over 3 times 1. So this, and then 3 cubed plus 1 equals. They have the same base, so we can subtract their exponent. Equals 3, 5 minus 3 plus 1 equals 3. 5 minus 3 is 2 plus 1. And then 3 squared is equal to 9 plus 1, that is 10. So this is your answer for number 5.